Okay, my name is Jeremy Mikola. Thanks for coming to this session. I'm going to talk a little bit today about, so I am mostly a PHP developer, but for the past 2 years I've been working on a PHP extension, which means that I got to go back to all of my college days and pull up all the C syntax and get back into the nitty-gritty of things. And so this talk is going to be going from just like introducing how we write PHP extensions and the relevant bits of C from the PHP developer's perspective. So in my day job, I work with, let me switch over. I work with these guys. The fellow on the left is Derek Reethens. He writes Xdebug and PHP's datetime extension. So he's pretty well known in PHP land. The guy in the middle is Hannes. He works on PHP.NET and keeps that up and running. And then I'm over there on the right. And we develop the PHP driver for MongoDB. So this talk, I'm not going to talk at all about MongoDB. But if you're interested in that, I have 2 sessions tomorrow on it. So before I got to MongoDB, I'd worked quite a bit in PHP. And I'd done all these other languages going back into writing TID3 calculator games in high school. And at the time, it was if anyone had that and you had like the Tetris game or something, you're like, Zend 9 assembly program, how does that work? So after college, I started doing some assembly for some defense contracting, and I really hated that. But I'm going to end up talking about mostly just PHP and C, and that's PHP is what I've done most of my time after university in. And then C, I kind of always remembered it, but learning how to write C for PHP was a dramatically different experience than just knowing the basics of C syntax. So specifically the topics that I want to cover today are, so when we look at PHP, what is the relevance to C that we find? So there's actually quite a bit. A lot of PHP is modeled after C, going back to like in the 90s when Rasmus first released it. It was based on a lot of old C libraries. And then I'm going to give just a crash course into C syntax, so that even just after the next 40 minutes, you can go and probably not write a complete PHP extension, but you can probably load one up and try and navigate your way around and see what it actually does. And so that's really helpful, especially like with the Mongo driver. We have people go report bugs to us, and sometimes they can dig up where they think in the extension code the problem might be. And then I'll look a bit at PHP internals. And kind of explain the education process I went to, because one of the things PHP is notorious for is having, as good as the PHP.NET documentation is for PHP functions, the actual internals of how things work, and if you want to learn how to write extensions, there's very little that's actually been written for that. So just to look at how to bootstrap yourself and get involved if you actually do want to dive into this in your own time. And then lastly, just look at the recipe of how we compile extensions, what the build process looks like. And that's kind of also like a general C library. There's a lot of relations to normal C libraries as well with that. So starting off with PHP and where we find C with that. So one of the easiest places to look is if we look at all the PHP IO functions. And maybe nowadays we might use third-party libraries and components that kind of abstract this with classes and things. But the basic PHP functions for doing opening files, doing writing to them, doing file close, all those I/O functions are basically lifted from the C APIs. And the same thing goes when we look into the PHP string documentation. We have things like strlen and all these 6-letter function names. So that's all taken from old Unix-style C libraries where 6 characters was basically the most that you would get for a function name. So that's why a lot of things are really abbreviated. But then that's where printf and sprintf comes from, and things like stringcar, which is looking for a character in a string. And so there's clearly differences where C doesn't have string types, it has characters, and so strings are character arrays. But in PHP we have these extra types that don't exist in C. So not all the functions behave exactly like they would in C, but they're kind of spiritual successors to them. And then if we look at the datetime functions, not the datetime component that Derek wrote, which is really excellent as a nice API, but the basic things like the time function, string from time, those also really just based on C functions. And then there's a bunch of other PHP extensions which are really nothing specific tailored to PHP, but if we look at PHP's curl extension and not the object-oriented side of it, but just the raw functions, a lot of extensions have the procedural style and then the object-oriented style. So things like curl or the older MySQL libraries, those are really just C libraries that someone decided to write extensions for PHP. So kind of map this PHP function over to a C function, and then there's just a little bit of glue to say, well, we have this C resource, we have to kind of track that in PHP. So at a bare minimum, that's how easy it is, or the least amount of effort that's required to turn a C library into a PHP extension. So that's how a lot of things do work. Whereas like with the MongoDB driver, there's a whole richer API on top of it. And then PCNTL doesn't map directly, but those are things like the exec functions, the ability to fork off processes and things like that. A lot of those are lifted from C APIs as well. And mostly in that case, Linux C APIs. So not all of these, you won't find all of these things in Windows. But just an example here to see just how parallel they are. So this is a simple file IO in PHP. And probably in like these days, you'd probably just want to use like file get contents and then take advantage of PHP streams or something. But just for the sake of example, we just basically just open the file, we get this file resource, and then we can write to it and then close it when we're done. And if we were to write a small C program that did the same thing, as small as possible, one, we'd have to wrap everything in a main function, because that's the entry point into a C program. And we also have to include the kind of the header file, which is like what are the functions that we're going to be using. So we're going to include the standard I/O, the prototypes for those functions, so we know how to access them. So that gives us the definitions of like what fopen looks like and what fputs and fclose. But like in this example, the functions are just directly named after each other, and there's just some small differences there. The other things that stand out is that whereas in PHP we enjoy our loose typing, unless we're playing around with HHVM and we want to take advantage of the static typing they're adding. But in C, everything needs strict typing. It says we're going to compile it, we're going to check our types and such. So when we write our PHP extensions in C, there's, even though we're working with these PHP mixed values that can be anything, on the C side of it, for PHP extensions, we do have actual C types for things. But that's the other thing that would, I guess, stand out here is that we actually have to say there's a file star, which is a pointer to this file resource. And we use that. And then the other types, which like the scalar types that we're all familiar with, like integers and booleans, floats, and strings. And so some of the language differences, just to summarize them, the source code in PHP, as we all know, it's interpreted. We can have it open in a text editor, save the file, refresh it in a web browser, or just run it in a PHP command line and get instantaneous results. Whereas with C, if you do that and run your program without compiling it, you're not going to get any of your changes. So C has to be compiled again every time we modify the source code. And the individual source files can be compiled separately. So one of the, we'll cover that in a bit, but if I have a very large C project with thousands of C files, and I only change a couple of them, then we really only have to compile just those files. As long as the other files have been compiled already, we can build the binary without recompiling everything. But the actual .c files do have to be compiled. And then the typing aspect is every time we have a function in C, there is no, there's ways we can cheat and take memory addresses to things in memory and kind of cheat with dynamic typing. But otherwise, everything in a C function, like an argument, will either be strictly be an int or a character or a memory address or something like that. Whereas in PHP, we can just send any value we want around. And there's no, everything is dynamic at runtime. The other thing to mention is scoping. So in a C library, if I had an if statement and I declare a variable inside of there, it exists inside the scope of those curly braces. Whereas in PHP, everything is at the function level. Then we also have these globals which hopefully we don't use anymore. But in PHP, you can register your globals and just have globally accessible $signs. So I'm not even going to talk about that anymore. I've said too much. And then from a memory perspective, in PHP, we think memory management is automatic until you couldn't allocate 13 bytes because we exceeded our memory limit, and you get a nice little 500 error. But for the most part, we don't think about memory allocation in PHP. We just do stuff. And if we happen to use a lot of memory, our script runs slow. Maybe later we profile it and we see that we're taking up a lot of memory. But in C, there's basically two ways that we use memory. One is when we invoke functions or we declare variables. We have memory that's, we'll talk about it in a bit later, but on the stack. And that's memory that just is allocated for us because we're declaring that these types need to exist. But then there's times where we need to access, maybe we're taking user input or we're reading a file, we need to create this buffer. So there's other cases where we have to ask the operating system, oh, I need 300 kilobytes of memory, so please allocate that for me and give that back to me. And then the flip side of that is when we're done with it, we need to say, okay, I'm free. You can free this up now. So there is no garbage collection that we enjoy in PHP. I do that in a long-running C program, and you'll just get memory leaks, and then people will complain, or you'll run the program out of memory. And so to give, starting with just a crash course in the C language, this is one of the delightful classics that you'll find on a lot of C developers' bookshelves. And this is Kernighan and Ritchie are one of the earlier C guys. I think they're from Bell Labs, but don't quote me on that. But I've already said it on video. So maybe they're not. But this was the original. I think this book was written for the C89 spec. And there's a more recent additions to the. I think one of the more recent additions to C was C99, and that's 1999. And then there's C 2011. So things move pretty slowly in the C world. But a lot of the classics stay the same. This is still a very good book to have. And so the topics and just introducing C that I want to talk through is first, like what is the purpose of header files and compiling? What are the different steps there? I'll look at static typing and static and dynamic linking. So this is when we build our C programs. We have the option of compiling everything into one giant ball of code, which would be the static perspective, or dynamic. And most of us, if you're using Linux and then you update all those lib whatever things in your package manager, those are dynamically linked libraries. So that lets us patch OpenSSL without having to recompile everything in our operating system. And then we'll talk about declaring things, different data types that exist in C, and just relate that. I think everyone's familiar with what exists in PHP, so we don't have to make the analogies there. And then I already mentioned this a little bit, but talk about the different ways that we deal with memory in C as well. And that'll tie into how we deal with PHP extensions. So the purpose of a header file. So these are things that in the little example I showed before we used any of the file IO functions, we included std.io. So std is just the common prefix for standard. And then this tells us what all the functions look like and what the different types that might be defined are. So when we had a file resource, the file star, so that also defined what that happened to be. And this includes things like, in addition to the type declarations, we might have constants defined, which would be kind of similar to PHP constants. And then the other things that you'll use a lot with writing PHP extensions would be macros, which are kind of like constants for code snippets, so kind of like inline function calls. So typically we have like a lot of macros to deal with with all the different types that exist in PHP. There's macros to interact with them and to access memory pointers and things in a consistent manner, instead of having to write out the verbose code completely. And then the other benefit of macros is that on different operating systems, we can define constants and macros with respect to, so on different operating systems, an integer might be different bytes, different amount of bytes, or we might have a big endian or little endian, like how the bits in a single byte are ordered. So when we deal with macros, we can have macros on different operating systems or different platforms still provide a consistent API, and so by using them, we don't have to think about what the actual C code that we have to use is. So think of those as just really a convenience. And then lastly, function prototypes. Those are really just declaring the functions if, like in PHP land, if we had abstract classes and we're just declaring what the prototypes might be. So this tells us when we, for statically compiled, it's not so important, but when we're linking to some external library, we need the header files when we build our program so we know what is the API that we're going to be calling. And so the steps of compiling and linking. With compiling, there's the preprocessor, and that basically takes our C source file, turns it into this translation unit. So it kind of just converts it into something that's ready to be compiled. And then the compiler actually takes that and makes the object file, and that is the actual instructions for the particular processor. Then finally, we take multiple object files, and so each C file will become a .o file, and then the linker turns it into the exe or just the regular binary that we then run. So in the example I gave before with if I had a very large project, I just modify one .c file. I really only have to regenerate one object file. The other object files for the other 499 C files can stay as is, because I didn't change the source code. So we basically, if I were to rebuild my project, we'd run the preprocessor and the compiler on the C file that changed. And then the linker, we still have all the other object files that were good to go before. We just combine them with the new one and generate the final executable. And with PHP extensions, they're really small enough where it doesn't make too much of a difference. But definitely in a large program, or like if you're recompiling MySQL, or God forbid, something like OpenOffice or Firefox on Gentoo, and take a few days to do this. And then the other thing to note is static and dynamic linking. And to relate this to PHP, you have PHP extensions that are included in your PHP binary. Recently, one of these that have changed was the JSON extension used to be just available in PHP, and now a lot of distributions package it as a separate JSON package that you have to install manually because of some licensing quibbles. But static linking basically means that these other libraries that I'm depending on, I want to make sure that they're built into my executable. I don't want to have any dependencies at runtime. So an example of this, if you're releasing software maybe for something like a Raspberry Pi or some embedded system where you don't have like an operating system with tons of external libraries that you can link to. So you just want to create a static library. I don't know if people are familiar with like BusyBox on Linux systems, which is like one little binary command that has all of your basic essential Unix utilities, like the copy command, the ls, dir, all these things. So static linking, you lead to these monolithic binaries, but it gives you full control over, this is what I compiled with, these are the other libraries I depend on. And in the case of PHP, we can kind of push one PHP binary off to a server, and it has all the extensions there. On the flip side, hopefully everyone is familiar with PECL in PHP, which you use to install PHP extensions. So it has like a pair-like interface for that. And so that's for when we install dynamic extensions. In Windows, they'd be a DLL file, but on Linux, it's usually a .so or .so something. And these are things that we're just going to load at runtime. And so this means that if we're depending on these, we compiled our program just against their header files, not necessarily their code. So we know what their API is. And then at runtime, we're going to rely on our operating system to go off and load the SO or the DLL file and to have it be accessible in memory. So when we're executing our program, we know that these functions that I compiled against, that I trust are existing in this API, they are available in memory, and then I can call them, and these are the arguments they take. This is what they return back to me. So this is certainly more flexibility. There's some slight overhead, because we're no longer dealing with the functions and stuff are no longer local inside of our little program that gets loaded into memory. So we might be running off into other points of memory in the operating system. But it gives us more flexibility where if we need to update one of those libraries, or say I don't want to have to recompile PHP just because I'm updating my MySQL driver or a new JSON extension or the Mongo driver. So having .so files get loaded at runtime could be more convenient for us. And so usually the overhead is not too much for PHP. This is definitely, a lot of people end up using PECL libraries for this. And then the last bit I want to cover is just declarations. So the one thing that you can do in PHP, but most people don't, because the syntax is a little obtuse. But in C, before you use any variable, you have to declare it, which is declaring it with the type, and then certainly what the identifier might be. And you can certainly say, like, int x equals 5. You don't have to split the assignment and the declaration into two separate things. But it's basically saying what the type is and what it'll be storing before you decide to make use of it. And so not just variables. This also applies to types. So there's the basic scalar types that we're all familiar with. But then C gives us ways to define like alias type names. So we might say one of the familiar types in C is a size underscore t. So in the standard library, they usually put underscore t for the custom types. And so size underscore t is basically the general size if you had an array, or if you're accessing, like, what is the memory size of this variable? It'll give it back to you as a size t. And on most platforms, that's just an integer, an unsigned integer. But there's an actual type for it, because on different platforms, maybe it's not an integer, maybe it's a long or a long integer or something like that. But the types let us have more abstract code and not worry about the implementation. And certainly PHP's internals use that as well. And then also just declaring the functions. Typically in the header files, You're not supposed to declare the implementations of anything. It's just the prototypes of your functions, what they return and what arguments they take and what the function name is. But for small functions, sometimes people do just declare them inline. We talked about the scoping. So every time there's a curly brace, that is when we declare things, they're accessible within that scope and they don't exist outside of it. And then source and header files, explain the difference between that. The header files are basically where we do declare things, and when people compile against our libraries, they depend on our header files. And then there's the extern and static keywords. So static is kind of like, since C is not object-oriented, so everything is really just procedural code and functions. But there's conventions people follow to kind of have well-structured source code. Static gives us a way to, if we're in our .c file, if we're declaring variables or a function in most cases, and we only want it to be, it's really only relevant inside this .c file. It's like a utility function. So I might declare it as static. Doesn't mean anything like it does on PHP when we have like a static variable or a static class function. Static in C means it's visible only to my .c file, so it's kind of private to the file where it's declared in. Whereas extern would be, I'm relying on some externally declared, I expect this to be declared externally. So extern is, I'm going to declare it, but I'm trusting that it's being implemented somewhere else when I go to link things. And lastly, there is the static keyword in the context of a variable, which is where every time the function would be executed, it uses the same memory for the variable. So you can have, similar to if you had like a static variable within a PHP function, where you can keep incrementing it. But those are, with respect to declarations, extern and static that's the context for them. And then the data types. So integers are most common, and they could be things like a character, which is usually 1 byte. So you think of a string as really an array of characters. Short is usually 16 bits. Int and long. And then usually the integers will range up to 64-bit, and sometimes they get a little bit longer. And they could be signed or unsigned. Floating point numbers, those also exist. Doubles are basically double the size of a float. And then there is no string type, which I mentioned. That's just really just an array of characters. And the array isn't really a type, but it's really just a sequence of the same values in memory. Which means that when we declare an array, we could either declare it statically and say this is an array of chars, and it's 10 of them. And so I could use that to store a string of essentially length 9, because I need room for the null byte at the end. But whenever we deal with arrays, we basically have to keep track of the length of it separately. So it's not like in an array of PHP where I could just pass an array around and then get the size of it, because in PHP, the data structure knows how long is this array, how many elements does it have. And it's also not in PHP, our arrays are really, a lot of times we use them like hashes because they're associative arrays. Whereas in C, its array is literally just a sequential sequence of things. So it always starts at 0 and proceeds upwards for the indexes. But that would be, without structs, it would be a lot more annoying to deal with these things. Structs basically let us group multiple values into one. So similar to a struct might contain, if we had like a point struct, might contain int x and int y. And then we can pass around the size of that struct would be the size of 2 integers, because they're just stored together in memory. And so we might have like a string struct that stores an array of chars and then the length of the string, and we have now that one value to kind of pass around. So a struct is just kind of like a basic data structure. Think of it like a class with all public properties. And so those are definitely also used in PHP as well, internally. And before we get into the PHP side, just a note on pointers and what they are, because this is a thing that C is probably very well known for. So pointers are conceptually just it just points to memory. It's just the memory address. So if we had these 2 variables, and the first one was A, and the variables have to be stored somewhere in memory. So let's say our program starts at memory address 0. So A happens to be stored in the second memory address, and the content of it is just another memory address. Which on most systems, when you talk about like 32-bit Linux or 64-bit Linux, is basically the size of the accessible memory address. So 64-bit machines have 64 bits, have much larger memory addresses to deal with. which means we could have more RAM, more accessible memory in the system. So that's basically the size of what a pointer would be on that architecture. And so we have this variable b, and that is also just a variable that might have its own value, and a knows that it points to it. So if we declare a as being a pointer to, if b happens to be an integer, I'd say, well, a is an integer pointer. That means I can pass it around and then access its memory location to get whatever the value of b happens to be, or whatever happens to be stored in 1008. And so pointers are types. As you saw in the earlier example, we had like a file pointer. So this is the really very same example. By default, and something that you'll no doubt experience if you work with C, if you get seg faults, that's probably, not always, but probably a null pointer exception, or similar to what null pointer exception in Java would be. That means that we have a pointer to memory address 0, and there's really nothing there. It's essentially uninitialized memory. Or maybe it's a memory address that we really don't have access to anymore. Maybe it was pointing to something that we allocated, and we freed up that memory. So we've kind of washed our hands of it, but there's still something pointing to it. So there's no safety harness in place to stop you from accessing bad parts of memory. And this is kind of useful because when you think about like how drivers and stuff works, dealing with like writing to USB devices or graphics cards, things like that, it's all essentially writing to memory addresses that are pointing to actual hardware. So we wouldn't want to take that functionality away. But inside a program, when you're pointing to actual data structures, if you point to the wrong place, or maybe we're pointing to something that's an integer and we're expecting it to be an array of things, we have the typing mixed up. Those are all reasons why you might get memory exceptions. And so the pointer assignments, the little ampersand will look familiar. Unlike in PHP, it's not a reference thing. The ampersand basically gives us the memory address of whatever the a variable happens to be. So that would store it at 8130, then the pointer would get 8130 as its value. And the pointer itself is stored in a different address. And then dereferencing the pointer using the asterisk, similar to how we declare it. Asterisk on a pointer kind of goes to the memory address that whatever it's being referred to, and then gets that value for us. So if this is a pointer to an integer, star PTR would give us back the value of the integer. In this case, we're saying dereference it and then assign this value to that memory address. So we can use these both for writing and reading. But this is the building blocks essentially that lets us do really rich things. We could even, so right here we're just dealing with basic types, but if you're thinking of, well, how would we model a class in C? We could have a struct, and the struct might have its data member properties, and then also pointers to functions. And so the struct itself, like a function is essentially just a pointer itself to a block of code. And so there's extremely convoluted syntax to how to deal with function pointers. But logically, that is, we can have pointers to functions and then have maybe different implementations. So if we had multiple functions that had the same API, we can replace the pointer with an equivalent function that returned the same value and took the same arguments. And so that's something that little C book would explain in a lot of detail. I'm not even going to try and go into the syntax for that. But pointers, a difference between pointers and arrays. So I said arrays are really just values sequential in memory. So if we were to declare an array of 4 integers, and we can use that syntax to kind of define all the values up front. We can have a pointer, A itself is really a pointer to the first element. And so when we use that bracket syntax, that's actually doing a little math behind there. When we dereference it and we do A bracket 0, it's essentially A is a pointer, and bracket 0 says dereference it and add 0 to the pointer value. Whereas when we do pointer 1, that's really equivalent to doing A bracket 1. So the bracket syntax says, well, what is the size of whatever we're containing? Because that tells me how many memory addresses I need to advance for the indexing. So the index is, even though the index goes 0, 1, 2, 3, 4, if the ints happen to be 4 bytes apiece, then index of 1 would be the address of A plus 4 bytes, and that gives us the second element, essentially. So it's really just a bit of arithmetic. The difference comes in if we want to use the size of operator. The size of a pointer is whatever the memory address happens to be. So that's going to be the size of whatever an int star happens to be, either probably 32-bit or 64-bit. But when we declare, and usually we don't declare arrays statically like that, because it's usually we want to have some dynamic size of the array. But when we do deal with size of, in that case, we know the size of the entire array since it was declared in code. Size of knows that, okay, this is actually 4 integers large. But beyond that, A and PTR are used equivalently when we use the bracket operators or if we use asterisk to dereference them. And so these are definitely quite equivalent. And so the difference with stack and heap memory, when I do a bracket 4 and then declare it to 4 ints, that's being allocated on the stack because I'm declaring it in place. But if I had some dynamic size of that array, I would need to go instead to the most likely the heap, which is a separate pool of memory. So whenever we need some memory dynamically allocated based on like user input or something that we don't know at compile time, the heap is a space of memory usually outside of our program. So it's a bit slower to access than the stack memory, which is really part of our program binary and part of the function itself. So stack is definitely preferable if we can deal with that, but it's certainly not always the case. So stack allocation example of this, one of the internal PHP functions is converting A to I basically means convert this string to a integer. And so this returns an integer back to us, and we take a pointer to a string. Const just means that the function guarantees that it's not going to change the value of the data that's being pointed to. So that's usually good for strings. And then we also have to pass it the length because the char star doesn't. We don't know how long the number of bytes there may be. And so internally, the char star was probably allocated by PHP. So dynamically, we said this string happens to be 40 bytes inside the C code. PHP needs to know that, well, okay, I have to allocate 40 bytes. I couldn't have anticipated what the script might do at runtime. Whereas stack allocation, I mentioned, is just really when you declare things, either your arguments to functions or what functions their return type. Or when we declare things like arrays like this is all declared in the stack. And heap allocation typically uses the main functions to be aware of our malloc, which stands for memory alloc. And then the counterpart to that is when we're done with it, we call free. We give the pointer back to free, and we say, we're done with this memory. You can release it back to the heap. And so the heap is really the shared memory for our program. So we'll take from it and then give back to it when we're done. And so this is an example of freeing the memory. So one thing that you'll want to do if you free a pointer, probably go set it back to null because the pointer is still pointing to that memory that was previously allocated to us. And free is not going to change it for us. So we have to, usually to be responsible, we'll just forget that memory address existed. Because if we freed it, we shouldn't be dealing with it anymore. Without this, it's much easier to get into a situation where you're accessing memory that you don't have access to, and then segfault. OK, so that's all I'm going to cover for the C essentials. Sorry if that was a bit dry. Let's talk a bit now about the PHP internals and what goes on inside of PHP. I'm not going to talk about the PHP internals mailing list, which is, if you've read it, is usually a lot of people bickering. I'm going to be talking about the actual PHP source code. So this is, most of it currently is on GitHub by now. These slides are a couple of months old. But PHP source is changed dramatically. The current version that they're working on is 5.6, which is in beta. And all these are just organized under separate branches. Basically, we rely on PHP core to do the heavy lifting for any PHP project. And so this is, if you were in Davey Shafiq's talk, and he was talking earlier today about HHVM and hack, to clarify that HHVM is essentially a drop-in replacement for PHP's the interpreter we're going to talk about now. So one of the things I was doing recently was writing HHVM extensions. And similar to where PHP core is written in C and the PHP extensions are written in C, with hack, their runtime is all in C++. So their extensions, which are also compiled SO files that get loaded, also happen to be, in that case, written in C++. But as an extension developer, we rely on PHP, and as a language user, we rely on it for the heavy lift. And it does the parsing, the compiling of the language. And there's hook points where extensions can add syntax to the language. So if you've followed some of the PHP PHP conversations on like mailing lists and things, you might have seen, well, there's RFCs where people are cooking up ways to add like scalar type hints to PHP, or new array like the first time someone added short array syntax. A lot of that was added by originally as an extension or a patch, and being able to add either things to the language grammar, which is, so not all of it is in C. A lot of the language grammar is in like YAC syntax. But other things like adding, it might be the most straightforward example is just adding a custom function to PHP, which is what a lot of extensions do. But internally, there's also lots and lots of macros for code scaffolding. So in my C code, the way I define what would be a dynamic PHP function that takes arbitrary arguments and returns an arbitrary thing, that's going to look a lot different than what a C function is. Because a C function, I know what the arguments are, I know what the return type is. Whereas in PHP, I might be dealing with like variable arguments or arbitrary values, or maybe PHP values passed by reference. These don't directly translate into C arguments or a C pointer. So PHP core provides us a lot of macros for, if I want to declare a function, I don't actually write the function declaration. I would say PHP underscore method or PHP underscore function. And that's this macro. I give it my function name, and then I immediately then declare the braces, and I can put my C code inside of it. And what the macro might do for me is abstract away all of it declares the return value for me, which is going to be some PHP data type. And so I don't have to deal with that directly. I don't have to deal with the overhead of parsing all the PHP arguments that might come in. So the macros are basically responsible for, if you look at a PHP extension and then you look at maybe the C projects you did in college, they look very different. And that's because there's the hardest part about writing PHP extensions is really understanding what macros exist and what are all what all these macros do. Additionally, there's lots of data structures. So representing a PHP integer is not really a integer in C, not directly. So in PHP, since there's garbage collection and things like that, and two variables in PHP one might be a reference to another. So that all has to be abstracted away in these extra data structures. And PHP needs to be able to keep track of, well, how many times is this variable referenced? Because with the last time it's no longer referenced, I can go free the memory for it. So internally, even though a PHP integer is basically does have an int value that I can get to from C, but there's a lot of other stuff on the side to it. And then there's also a bunch of utility functions for dealing with the horror that is a PHP array. And is that an array, or is that a map? Is it a vector or a hash table? So there's utility functions where I don't have to think about that. I just have these hash functions that I can deal with, and that can do the same thing like we have in PHP, where I could do isSet. I could check if a hash key exists and give it an integer or a string. So that makes development a lot more convenient. And then from a memory management perspective, PHP has its own API for memory allocation. So whereas in a normal C program, you might be using malloc or tcalloc or these other alloc libraries, in PHP, the memory you allocate in your C extension, you'd like it to be able to be freed by PHP. And likewise, the PHP extension has different levels of lifetimes. There's if you're using, say for example, Nginx, and you're using PHP FPM, so you have these worker processes, and each worker process maybe serves 40 HTTP requests, and then it kills itself off. And so if there's a memory leak, it's only going to last for 40 HTTP requests and then kill itself. But an extension has the ability to allocate memory. So something we do in the MongoDB driver is we want to connect to the database, but we don't want to do it every time an HTTP request comes in. So we need some way to store these connection resources outside of the memory scope for a PHP request. So depending when we allocate stuff, we can say, well, this should be persisted between. So basically, I want to allocate this, and I won't clean it up until the PHP worker process ultimately dies. And that's when my extension gets unloaded. But then inside of a request, there's also hooks that, well, every time a request comes in or a request ends, my extension can do something or clean its memory up. So in that case, you'll have bits of memory, things that and usually things with like database drivers that you'll want to have stuff persist between requests. Otherwise, you'd like stuff to be cleaned up every time the request ends. And the last bit, which is not too relevant because PHP and threading generally doesn't work too well anyway, but there's completely different programming APIs for dealing with if you're on a threaded PHP instance. And so this is really an afterthought when we develop, when you write a PHP extension, because there's very simple macros. We basically stuff this 5-letter TSRM for thread safe resource manager. We basically stuff these macros into all of our C function calls inside PHP. And then if we're dealing with threading, it's defined as something, otherwise it's not. So it's really just a convention. You just have to remember to pass around some of these macros. And they're both macros and constants that we pass around. But that's an example of we don't have to think about what the platform is. We can write our code with this particular convention and rely on PHP core. If PHP was compiled for thread safety, then those macros actually do something, otherwise they don't. But we just pass them around anyway, just in case. And navigating the PHP source code is quite daunting. So this is an invaluable tool. If you are writing stuff down, definitely write down this URL. LXR is not specific to PHP. That's why it's on a subdomain. But it's basically a cross-referencer for identifiers inside the code. So an example of this is basically what the UI looks like. And they've actually recently added, they started indexing HHVM source code as well, because this isn't specific to C. But basically, on the right side, we could pick what version of PHP other implement would be, things like HHVM. Or look at PECL extensions as well, or a particular branch. And we can basically look up, if you want to see where a particular, maybe where zval, which is the structure that stores a PHP variable, that could be anything. We want to see where that's really actually defined. If we were just to grep the source code, we're going to find tons of references to it that we don't really care. We want to get to the root of it, like what does this struct actually look like, and where is this macro actually defined, not the thousands of places where it's actually used. So this really narrows it down. So if I were to look for array values, I want to see what the PHP array values function does. So this example, earlier I said there was these macros PHP function and PHP method for defining function and method bodies in C code. So just to kind of walk through this, but LXR will take me right to, it's under the PHP 5 branch, under an extension, and there's some core language stuff, but usually when you're looking for things that you think are in PHP core, they're actually in the standard extension. So it's like a giant pool of common functions. So that's where you'll find all the array functions, all the string functions, and things like that. And this is a way that a lot of first-time contributors to PHP core start. They say, so Ben Ramsey has a talk that he's done in a few PHP conferences about his journey of, and it's also a blog post, his journey of contributing to core. He made an array_column function. And so his experience, he has a great presentation on like all the work it took just to get something like this added to PHP, from going to the mailing list and talking to people on RFCs and things like that. But just kind of walk through this, what the function does. So PHP function is a macro, and it's going to have all the actual C declaration stuff for us, but we don't have to think about what the actual, even the name of the C function is, because it actually gets this convoluted large name. Things get prepended and stuff to it, and array values does show up in it, but there's other stuff there. And then zvals, I just mentioned briefly, are, since PHP variables basically store anything at all, and they can also refer to other PHP variables, and they get garbage collected by PHP. So zvals are these structs, and when we're dealing with them in C, we are usually dealing with pointers to them. And pointers are useful because we can send a pointer. If I want a function to essentially take a value by reference and then modify it, I can't send in maybe the entire struct, because that actually would then have to get passed around in memory. That's kind of too big, but it's easier for me to just send in a memory address to a function and have that modify the value. So that's why a lot of the internal C functions will actually take pointers to things, and then sometimes you want to change what the pointer points to. So we have pointers to pointers, and there's really no limit to how many levels of pointers you want to have. But after PHP function, we want to be able to parse the parameters, and this is parsing whatever arguments got passed to the PHP function, not our C function, because they're really quite different. So our C function is really internally just getting a handle to how it was invoked in PHP. But we have these in this case, this is an actual utility function, and zen_num args is going to be a macro that just accesses how many arguments actually were there. This is us passing around that thread safe thing macro, which may or may not be defined as something. We have an inline static string A, so Zend parse parameters lets us kind of validate that parameters are something. So we can use something like Z to say any Z val, or we can send in values that mean the first argument should be a float, or the first argument should be an array. In this case, Zend parse parameters, I demand that the first argument is an array. And so there's plenty of PHP functions where you expect an array and you don't pass in one, and you get that nice error message that says expected parameter 1 to be an array. It was actually blah, blah, blah. That actually is the result of Zend parse parameters, because we give it kind of a string dictating what the format of parameters that we expect may be. And so if this fails, we just return early. Otherwise, we kind of work with some other, and these are some of the Zend hash functions that I alluded to that it's certainly more verbose than doing stuff like isSet and then iterating, but all the APIs are actually are there and convenient. Once we learn what basically Zend, everything is grouped under Zend, then there's everything under hash deals with essentially arrays. And then from there, the while loop is basically just doing the iteration through each of the values and keys. And so when you're navigating the source code, a place where you can expect to find everything, the core source and the syntax is going to be under the Zend directory. And this is where you're going to find things like the parsers, the actual types are defined there, and internal API stuff. Internal API being like all the Zend hash functions, stuff like that. The things, if you're looking for where is my PHP function actually defined in C, you're going to probably look under ext/standard, or you'll find the other core extensions like MySQLi. I don't know about curl, but things like datetime is certainly under there as well. And then a lot of the external ones like the MongoDB driver were not in core. Those you'll find in PECL. Server APIs, so those are like FPM, the CLI environment, or maybe mod PHP. That would be under SAPIs. And then tests live in tests. So just a quick talk about tests. So this is Chris Harchis, the grumpy programmer on Twitter. And we're supposed to stop using this picture because it's been overused for the past 2 years, but it hasn't been used enough in Utah, so here it is. So in tests in PHP core, they have their own proprietary format because why not? PHP t-tests are basically, they have a name, they have some code, and they have expected output. There is no assertions. If you want assertions, you echo it and you put what you expect to see in the expected output. And we use this both for PHP core and for extensions. It's really single purpose, so a project would have PHP core has thousands of these. So array values might have many of these, and it's testing each individual test case as a separate PHP file. But they're also debuggable, and the documentation for how this works is on qa.php.net. So you might ask, well, why wouldn't we want to use PHP unit or PHP spec? And so the problem here is when you're writing, you're essentially trying to test C here. And so if there's a seg fault and you have to go through a backtrace, do you really want so many frames of Sebastian Bergman's PHP source code to be in your error trace? So in terms of debugging, to actually have a single isolated PHP snippet of PHP code, and if this seg faults, there's probably much less of a stack frame to go through, and I can immediately look through the backtrace and open up GDB and start poking around in memory addresses and see what I'm accessing. So we really want the overhead to be as low as possible for running these, and it's also useful because PHP tests, when we run them in like a build suite, we can catch memory leaks and things like that. So that's the more isolation, the merrier in this case. So just an example of what this looks like, a PHP test for maybe the string car tests. I might just var dump a couple of test cases here and then my expected output. And so PHP-T will run whatever is between file and the expect, and then just do a diff between these 4 lines and whatever lines are echoed by the PHP script. And so that's why we don't want to put too much in here, because then the diff could be unmanageably large. But also it would kind of be lousy if we just had one var dump in one file at a time. So there's usually a trade-off. You want to do a couple of related tests in one PHP-T file, but not too many. And since I am giving a PHP presentation, I will talk briefly about zvals. There you go. So PHP variables, I mentioned zvals a couple of times. So it is The first thing up there is a union, which is basically all those types basically occupy the same memory address. And so this union, we're using typedef because I don't want to have to refer to this as union zval all the time. So I'm giving it this nickname zval value. And this union could either be, I could either access a long, a double, it could be a string here, which is essentially the char star and the int, or a hash table, or some other object value. And this means that I'm only going to store one of these at a time, because C will let me access this as any of these types. So I better access it consistently, otherwise I might store it as a double and then try and access it as this string struct, and I'm going to get completely garbage data. But the union lets me consolidate it in memory so that I'm using as basically the least common multiple of however large these are. So the largest one is probably the struct, so that would be the size. And then the actual zval itself, and that's an actual struct, so these are independent fields. We have the literal value in place. The ref count is for garbage collection. The type is going to tell me how I should be accessing this union, how I should access .value. And then another checking if it's a reference for garbage collection. And so this exists. It's helpful to see what the struct is actually defined as, because then this really helps to, well, now I see how this maps to every type in PHP. And thankfully, there's tons of macros to deal with. Well, give me the type of a zval. And the macro will go and figure out and read the type for me. So I don't always have to access .type. I can just send around a zval or a zval pointer and have PHP internals do it for me. And so see, these are some of the macros. So given a zval, I can access it as an L value or a Boolean value, double value, et cetera. And then when I deal with pointers or pointers to pointers, there's macros for those as well. And I'll stick around after for questions. Macros everywhere. Just a quick look at how we actually compile things, as I'm definitely running over here. So the main ingredients are the config files, which tells us other libraries we might depend on. Essentially, we need a .c and a .h file for our extension, and then maybe some tests. And the programs are going to run the first thing. It's difficult to compile on Windows, but certainly it is possible. The first thing we do is PHP-eyes, which comes with PHP's dev packages, and that will generate the config file for us, and it makes sure that we point to the correct PHP binary in all the PHP libraries. So this is going to point us to wherever the PHP header files happen to be. Next, we run configure, and this is common for most C programs. This basically creates our make file that tells us how to compile the project. But this does things like detecting what exists on our system. So if I'm compiling and I maybe have an optional dependency on libjson, my configuration file will pick up that dependency and then conditionally say when I build, I'll link against JSON because it's there. But configure does the checking for me. And then the final compilation is make. And so you actually, when you install something in Peckle, if you watch the logs, you'll see all three of these run in tandem. And the best part of this is since you're compiling, you have free time for sword fights, whereas in normal PHP land, you would not. OK. I'll have the slides up on Twitter, and they're HTML slides, so all these are actual links that you can go to. But these are excellent resources which helped me pick up from knowing absolutely nothing 2 years ago. And then one of the certain things to go look up later is on the PHP wiki, the internals references happens to aggregate a bunch of these as well. So thanks, you made it through. If you have any feedback for me, this is the joined in conference, the talk session, and I'll stick around outside for questions. Thank you.